So in section 3, we're going to look at polynomials and we're going to deal with multiplying, adding, subtracting, evaluating polynomials. Now, it starts out in 3.1, so lesson 3.1, and the title of lesson 3.1 is What is a Polynomial? So you can read the learning objectives there, but the main goal is to talk about classifications of polynomials and how we classify and categorize polynomials. So we'll see what a polynomial actually is. We'll talk about some vocab terms like variables and coefficients and all that kind of stuff. All right. And I'm sure you've encountered some polynomials in your other classes. You've seen polynomials. What we're going to do is we're going to add to that, hopefully, and do some evaluations and other stuff. So you can see here that polynomials are algebraic expressions that are created by using numbers and variables. So any number by itself is a polynomial, any variable, any number times a variable, any number times a variable to a power, or we can even have multiple variables, okay? Now, each one of these is a single term. And what you can do is you can add and subtract terms to make a more complex polynomial, all right? So, for instance, if you were going to make a more complex polynomial, you could say like 4x to the fifth minus 6x to the third plus 5x minus 19. That would be a polynomial. Obviously, it's an algebraic expression that involves these numbers up in front. Those numbers in front of each variable to a power. These numbers are called the coefficients. The variables, obviously, in this case, are the letters that represent unknown numbers. We've dealt with that before. And we have exponents. Now, these numbers, these coefficients here in front of our variables, they can actually be anything we want them to be. So, for instance, if you did 8/3 times x to the fifth, that would have also been a fine term to have in your polynomial. So it's okay to have fractions in your polynomial. In fact, another thing it's okay to do is to do something like 7x over 3. 7x over 3, excuse me, let me roll this down, is a nice term to have in our polynomial because, in fact, whoops, if you think about this, you could have rewritten this as 7/3 times x. So you could have written it as a coefficient times x. Now, what's not okay, so these things are all polynomials. 4x to the fifth minus 6x to the third plus 5x, 8/3 x to the fifth, 7x over 3. Those are all polynomials. So what's an algebraic expression that's not a polynomial, you may ask? Well, in order for it to not to be a polynomial, basically these exponents have to be a weird number, or I'll explain what I mean by that in a second, or you could be dividing by x. So for instance, let me go here. So these are all polynomials. Let me write that down here. What are not polynomials, what we're not allowed to do, is to do something like, you scroll up, 6 divided by x. Now notice the subtle difference here. 7x over 3 was a polynomial, but because we weren't actually dividing by x. Really, again, if we were to rewrite this, we were essentially multiplying by x. So it's okay to multiply times variables. It is not okay to divide by variables. And Because it's not okay to divide, we'll see later that this means that the only exponents that are allowed are positive, or I should actually say non-negative exponents. So you see here we had 4x to the fifth. That was perfectly fine to have x to the fifth because that x to the fifth means x is multiplying itself by itself 5 times. So this is like 4 times x times x times x times x times x. So this is repeated multiplication of x. What's not okay is to not have repeated multiplication. So if you had, for instance, 4x to the negative 3, that is not repeated multiplication because that negative exponent makes it not a polynomial. Also, we'll deal with these in section 3 too, but if you had 4x to the 1/2, whoops, let me undo that real quick. So, whoops, 4x to the 1/2 power. A 1/2 power or even any decimal version power is not okay either. All right. Now the one we're going to focus on is this one, 6 divided by x. And we'll see in section 3.2 that when you take x to the negative 3, that is actually equivalent to a division as well. You'll see if you keep going in our courses that in Math 105, you'll understand that x to the 0.5 power means square root of x, so that's not allowed either. So hopefully you understand this. Not a polynomial when we're dividing by x or when we have a negative or a decimal power. It's perfectly fine to have decimals as coefficients if you did negative 6.2 or 0.5 times x. Decimals and fractions are fine to have as coefficients, not as powers. Hopefully that all makes sense. So let's take a look. As you can see, this is what we just did. You can, by the way, as you do this, you can multiply multiple variables together as well. So let's take a look at these cooperative group problems. We have 8 different cooperative group problems. So what I'd like you to do is push pause on this video and then try those cooperative group problems on your own and decide which ones are polynomials and which ones are not polynomials. I'll give you about 5 seconds again to push pause and then I will go over them. Right, so hopefully you pushed again and try these on your own. Push pause on the video, try them on your own. If you haven't, do it right now. So 27 is in fact a polynomial, right? The single term where don't have any variables around, so that's not a problem. 5h, also a polynomial. By the way, whenever you have 5h, that h is actually just raised to the first power. So anytime you see a variable by itself, then we assume that that is raised to the first power. Now, number 3 is 27 divided by 5h. You can write it that way or the way I had it. That is not a polynomial. All right, because we're dividing by h, that's one of our rules that we cannot do. Dividing by h is not okay. Dividing by any variable is not okay. 5h plus 27 is a polynomial. 5 over 27h, that is a polynomial. Again, it's okay to divide by 27, but you can't divide by the variable. So since the variable is being multiplied, we're fine there. H squared minus 27h plus 5, that is a polynomial. H squared minus 27h plus 5 divided by 3 is a polynomial. Notice that all of our variables are up here in the numerator, so we're never dividing by a variable. All of them have nice non-negative exponents. And then this last one, 8 here, is not a polynomial situation because of the dividing by h. So again, the big thing is we cannot divide by h. We'll continue on 3.1 in the next